Hi everyone, this is Carl. So just going on, this is going to be a t-test example, kind of walking you through the steps and walking through kind of proving whether or not there's a difference. And so for here, the director of a company wants to determine if the changes in their program result in better productivity. She selects 25 customers at random and to identify the rate of production before and after implementation of better equipment. So in short, the manager installed better equipment to make their employees more efficient. There's a kind of a pre and post here. I'll just kind of spread this out real quick. There's before and there's after. And the difference between the two, that's what this denotes right here. So what we have here is just the employees' numbers, their efficiency output before, their efficiency output after. So we want to figure out exactly if there's a difference between those. And now one of those things, comparing the sample means, is the t-test. And so we'll go to data, and then we'll go to data analysis. And then what we can do is scroll down, and we are looking for the paired two sample for means. So what we're going to try. We're going to see if there are differences so that when we prove that if the means are different enough, then that there is a distinction, and therefore the equipment does have a measurable impact, empirical impact. So we'll go ahead and select this test. So variable 1 range, we have our variable 1 range, it's this one right here. Just going to scroll down to our values. That's variable 1. And then we're going to variable 2. Same case. Go up, and there's our values. And I wanted to click here because this denotes we have our labels up here. And so our hypothesized mean difference, the null is 0. So we're looking at alpha on a 95% confidence limit. And so we're going to put our output maybe just to the left of our problem, just right here. And so we're going to go ahead and get this started. Then we want our output range right here. There we go. And we're going to go ahead and get this going. Okay. So I can see this is our output that we have after doing it. So before and after. So part of, and some of these numbers are important, the degrees of freedom, test statistic, but what we want to do, I want to show you what we're looking at. So our first one would be, our first important value would be this one. And then our second one would be the one tail here. And partly because this is just a one-tail test. We are testing the value at the one tail based on our construct. So to determine the critical value, our critical value is this right here. Now because it's a one tail, it is negative because the left tail is the negative side. If you think of a bell curve and our distribution, and you put it down the middle, to the right is positive, to the left is negative. And that's why when one tails, we're looking at the negative dimension. So we're going to go equals 1 equals negative, and then this is our value right here. This is our critical value that we're using, negative 1.72. Next, calculate the test statistic. Use the t-test statistic. So our test statistic in Excel, it's actually called the t-stat. So that's this value right here. So we'll do that. We'll cut this, and that's our test statistic. So, conclusion. So if the test statistic, which is this, is less than or equal to the critical value, and that's the case, yes it is. So we reject the null, and the program is successful, and implementation is successful, because our test statistic is less than a t-critical value that we have. So that is the t-test paired two sample for the means. I hope this helps. And just let me know if you have any questions. Thanks so much.